In this video, we're going to look at a few common ggplot graphs that we want to make. It turns out we can pretty easily change the type of graph we're making with ggplot just by changing the geom function that we're adding. Often, we can even leave many of the same aesthetic mappings as they were in a different geom function. We just need to make sure that the required aesthetic mappings for any particular geom are present. Here are 4 different ways that we could visualize the distribution of one continuous variable. We could plot a histogram using the geom histogram function. The only required aesthetic mapping here is the column that's going on the x-axis. We could also create a density plot. This works by using an algorithm to estimate the relative amount of points at any age based on the distribution of the data. It's kind of like drawing a rough line through the top of the bins of the histogram. Again, we only need one required aesthetic mapping, which again is the column that's going to go on the x-axis. In the bottom left, we have a box plot. A box plot is a different method of visualizing the distribution of one variable, where we draw a box around the middle 50% of the data. In other words, we have the 25th percentile observation on the left edge of the box and the 75th percentile on the right edge of the box. The thick black line in the middle of the box is the median value, or the 50th percentile. The lines to either side of the box show the extent of the data. Finally, in the bottom right, we have a violin plot. This is kind of like a combination of a box plot and a histogram put together, or another way of thinking about it is it's like a density plot that we have reflected so that we have the density line both above and below the x-axis. The thicker the violin at any point, the greater the density of points at that value of the variable on the x-axis. What's a bit different about the violin plot is that y is the required aesthetic mapping. However, we want our violin to be horizontal to match the other graphs, which means that actually we want to put our variable on the x-axis like we've done here, x equals age. However, the violin plot won't work unless we put something on the y-axis. So here we've just put an empty character string, opening and closing quotation marks with nothing in the middle. The two continuous variables, in other words, to see the covariation of one variable versus another variable, we want to create a scatter plot. For that, we can use the geom point geom function. Here we now have two required aesthetic mappings. We need to specify what variable is going on the x-axis and what variable is going on the y-axis. Sometimes when we have two continuous variables, we may also want to show a trend line capturing the pattern of covariation. We can create a trend line with the geom smooth function like you see here. However, just showing the trend line by itself is not very helpful because we usually want to see the underlying points as well. Sometimes a trend line by itself can obscure the true pattern behind the data. For example, when we plot both of them together, we can see that we have a lot of values of cholesterol that seem to be 0. Presumably these are mistakes, or maybe the value was not recorded, and so whoever created the data set entered a 0 for these people instead. What it means is when we plot the two geoms together, both the scatterplot layer and the trendline layer, we can see that the trendline doesn't really go through the middle of the rest of the points. It's been dragged downwards by the cholesterol values at 0. This is why it's helpful to plot both of these types of graphs together. The way we can add multiple geom functions to a graph is just by adding successive geom functions onto the end of our existing graph code. So as with all our graphs, we start with the ggplot function. Then we have the addition operator, the plus symbol. Then we add our first geom function, which in this case is geom point for the scatterplot layer. We have the closing bracket here of the geom point function. And then we have another addition operator, another plus symbol. And then we add our second geom function, geom smooth. So we can keep on adding more and more geom functions to any ggplot graph, and it will just build up the graph as a series of layers. One thing you may have noticed, if we go back a slide, is that the geom point function and the geom smooth function both have the same two required aesthetic mappings. They both need a variable on the x-axis, and they both need a variable on the y-axis. In this case, we've got the same variables being mapped to both of those axes in both of those functions. So we've had to repeat ourselves a bit. We can actually specify a default aesthetic mapping when we're creating a ggplot graph. To do so, we put the mapping argument inside the ggplot function. So now ggplot has two arguments in this example. The first argument is data, where we supply the data frame. The second argument is where we put mapping. And we've got the same mappings as we had on the previous slide, age on the x-axis, cholesterol on the y-axis. But now we don't need to write those aesthetic mappings inside the geom functions. Instead, the geom functions by default will use whatever mappings were supplied to the ggplot function. Thus, we can prevent having to repeat ourselves a bit with code. If you ever need to override any of these default aesthetic mappings in a particular geom function, you can just add the mapping argument back into that individual geom function. The other nice thing about ggplot is that because it's part of the tidyverse, it expects data as the first argument. That means we can pipe a data frame to ggplot, which means also we can pipe the output of any function that creates a data frame. So if we wanted to get rid of those cholesterol values at 0, we could filter those out with the filter function, and then pipe the output of the filter function, which in this case would be the data frame without any 0 cholesterol values, onto ggplot, and then use the same code as before. And then we see we have the same graph minus the 0 cholesterol values, and now the trend line seems to go much more through the middle of the data. We can also customize how our trend line is created. The previous one was a squiggly trend line that went through the sort of average point at any value on the x-axis. However, we can also create a linear trend line with the same geom smooth function. All we have to do is add an extra argument where we change the method that's used to create the line. If we want a linear line, we would say method equals lm, like we see here. For categorical variables, we can again create a bar graph. In this case, we just need to switch the geom function to geom_bar and make sure that we supply a categorical variable mapped to the x-axis, which is the only required aesthetic mapping in this case.